Thanks for joining us and welcome to OpenInfra Live. OpenInfra Live is the Open Infrastructure Foundation's weekly show sharing production case studies, open source demos, industry conversations, and the latest from the global open infrastructure community. This is episode 9, and we have some great content coming up in the next few weeks, so I hope you can join us every Thursday at 14 UTC. My name is Thierry Carrez, and I will be your host for today. We're streaming live, so we'll have plenty of opportunities during the show for Q&A. Please drop your questions into the chat throughout the show, and we will answer as many as we can. Today's episode is part of a series on large-scale OpenStack infrastructure, promoted by the OpenStack Large-Scale Sale. We invite operators of large-scale deployments and get them to present how they solve a given operations challenge and discuss live between themselves their different approaches. 3 weeks ago, on episode 6, several operators joined us to present how they tackle OpenStack upgrades. OpenStack is released every 6 months, and keeping up to date with the latest version is often cited as the #1 pain point, especially for larger deployments. We had great presentations on that show, but we could not really have a good follow-up discussion and answer that many questions. So we decided to program a new episode to have that longer discussions on upgrades. So let's go ahead and get started. Returning today, we have Joshua Slater, Senior Cloud Systems Engineer at Blizzard Entertainment, Arnaud Morin, Site Reliability Engineer at OVHcloud, Mohamed Nazer, CEO at Vexxhost, Imtiaz Chowdhury, Cloud Architect at Workday, and Belmiro Moreira, Cloud Architect at CERN. So to kick off the discussion, I'd like to start with a question. During the part 1, some of you explained the motivation behind upgrading, but I would like to ask everyone a slightly different question. What are the trade-offs of falling behind?
I can briefly start with this one. So some of the advantages that we found of being up to date, which I guess will give us some trade-offs, is having access to the community and all the things that it kind of provides us. The more the OpenStack community maintains a set of releases, some which are called supported, some which are called extended support, and some that are completely unmaintained. So the closer you are to the supported versions, the easier it is to get your bugs fixed. Obviously, if there's any bugs that are fixed, it's going to be fixed in the most recent release and probably backported. And in my experience, developers do a good effort in backporting fixes, but they're not going to backport it like 6 releases behind. It's just a lot of work. There's going to be merge conflicts. So you're a lot more likely to get your fix backported or in the newer release that you're running. And then obviously, things like security updates and stuff like that are obviously important. But that's been one of the main drivers why we really aim to stay on the latest release.
Yeah, we've been really trying to maintain stability as like our top priority. So when we land on a release that we know works and is predictable, like maybe it does have some problems that have been fixed in a newer release, but we know what those problems are. We understand them very well. We tend to stay on it as long as we're able to, until there is a release that has like that big feature that we're like, okay, like that's the killer feature for us to finally go ahead and upgrade. And then at that point, we're able to kind of accept kind of the little bit less predictability on what the new issues might be in the new release. And then, of course, when you fall behind, sometimes the database migrations sometimes get a little bit less predictable. So we do kind of have that trade-off. The farther we get behind, the harder it might be to actually perform the upgrade.
Yeah, for us, the #1 reason is security. And then I would say stay close to a supported release. It's not so much new features. Like we see some new features once in a while that we need to, but security and stay on top of the latest patches are the main reasons for upgrade.
Yeah, it's for OVH. It's a mix of all the thing you said. It's if you stay on an old release, at the end you will end up in a situations with security issues. You can end up with I don't know, an open SSL library which is deprecated, and if you want to upgrade, you cannot, because your upgrade your OpenStack old version will not work with the new OpenSSL version, or situation like that. So you have to upgrade at what point before your deprecated based software is going to be very painful. And the second thing is about having new feature, because usually when you want to introduce new features, you want to they are developed on the new OpenStack release, of course. So if you want to introduce them into your old OpenStack, you can still cherry pick, bring back, but you will have conflicts, and it's more complex if your OpenStack release is older. So that's the two main reasons for us.
So, sorry, go ahead, Bomira.
Well, I'm going to give you what we do at CERN. So at CERN, what we try to do is always to run the latest releases. And basically, you touch all the points that I was going to mention. For us, we get the support from the community. So running the latest releases helps us a lot when we find an issue and we expose that issue to the community. And just to explain the issue, it's much easier to explain it in the latest release than we go back like 5 releases. And because then even for developers to reproduce that is extremely difficult. Then another point is upgrades. If we are running the latest release, then we only do a jump for the next release. And that is very well tested right now by all the OpenStack CI. If we are skipping releases, then we are putting a lot of things in our shoulders. And we need to do all those tests ourselves and making sure that everything will work fine. And we are increasing a lot the work and if we do that. And then there are the features and security patches that are always welcome.
Yeah.
Mohamed, go ahead.
And I think you brought up a really good point, which is the community. I think the majority of us here are running like community supported. So we work directly with the community and we use the open source versions of OpenStack. And so with that kind of comes this thing that a community can only support, so much back releases. An example of that was Ubuntu 16.04 was EOL'd, I think 2 months ago. And I know of kind of like a company that was relying on someone creating packages that were shipping for 16.04. And this individual was like, no, that's EOL'd, I don't have time to supply these packages. And you suddenly find yourself overnight in a situation where you can't deploy anything anymore. All of your stuff is broken. And those kind of general community maintainers are like, you know what, like it's EOL, there's not much I can do. And there's only so much resources I can dedicate for this because, I'm not in the business of providing a long-term supported version of the packages as a personal project. So I think that's a big, important part.
On the question of about skipping releases, I think that is something that we commonly do, and there are of course releases that you cannot skip. The one example was when like Nova Cells was introduced. We absolutely had to upgrade to that version, and if we wanted to go to a version after that, upgrade again after that. So, but we do commonly do that because we're not able to keep up every 6 months for sure.
Yeah, that's exactly what we do. Also, we just we skip a lot of releases, but we play every migration script on the database in order to make sure that everything will be. I think it's a fast forward mechanism. This way of upgrading, you just play migration script for each release, even if you are not targeting it.
Yeah. And I agree with that. And I think that one of the things is generally, the more you're involved with the code, you'll kind of start to get a feel for the different projects. So for example, a project like Keystone, I mean, it's a relatively simple API with a database backend. And so a lot of times, other than testing it, you sometimes can just go into the code, start looking at the migrations, and you'll notice, well, there wasn't even a migration in this release. So you can just go ahead and skip it because there was no changes in the database for that release. But some other projects like that will have a little bit more of a complexity. Things like, I think Nova and Neutron are things that I'd be less confident playing this game of going and jumping releases. Yeah.
So what I said is, at least in our case, is what we aim. So we try to be very close to the latest release. However, is not what we have. If we see what we have today, so CERN runs from Stein release to Wallaby. So we have projects between all these different releases. And it's precisely what you mentioned. It's completely different to upgrade projects like Lance, for example, or Keystone, or upgrade Nova and Neutron. And then when we upgrade, there are so many other factors like operating systems as well. So distributions don't build packages for the latest releases. For example, you don't have the packages for the latest releases on CentOS 7. So it means that we also need to plan first the upgrade of the operating system before going there to the latest release.
That's actually a good segue to the next theme I wanted to ask questions around, which is around the upgrade frequency. So in part one, we could see really that everyone had a different approach to their deployment and how they upgrade them. In terms of frequency, we went from Vexxhost upgrading everything to the latest version, CERN, like Belmiro just said, upgrading to each new version, but each service being independently upgraded, to others doing more of a big jump approach. And the community's position on this is to stay on relatively frequent upgrades every 6 months, and but make it easier to upgrade several releases at the same time using a fast-forward upgrades. So I was wondering if you could comment on how happy you are with the way you do it, or if there is like an alternate approach you would like to be able to do, and if you have considered doing fast-forward upgrades.
So I can start if you want. We are doing big jumps, upgrades, mostly because we are not able to do small steps. We would love doing small steps, small upgrades like Vexxhost or Mohammed is doing, but it doesn't work with our way of working or release cycle on the architecture. So we do big upgrades. We try to do an upgrade every year or 2 years, but while we are working on an upgrade, usually before it's completely done, the version we are targeting is already end of life, because it's hard to upgrade everything in one step. You have to planify everything, so it's kind of a complex thing, and it takes a lot of time. So yeah, we do big jumps. It works correctly. What we have to take care is the upgrade of the database and the data itself. It's the most complex part for us. Yeah.
Yeah, we're usually upgrading each service at a time, like CERN does as well. Like we'll have different services on different versions, because obviously some are very easy to upgrade. Some are a lot more difficult. Like Nova and Neutron tends to be on the oldest version out of all of those. Yeah, we will usually, we would like to upgrade at least every 1 to 2 years. For Nova and Neutron itself, we'll probably upgrade some of the other ones a little bit more frequently if there's a feature or security update or something that we need to get that version in. So we're usually prompted by a killer feature or security update to get a new version of that service upgraded. But for Nova and Neutron, that's kind of our major like trailing services that'll probably be on the older versions and take the most time for us to test the upgrades.
Yeah.
For us, sorry.
No, sorry. Go ahead, MTS.
Okay, yeah, for us, we've done big jump and not so frequent, very similar to, let's say, OVH story. It is difficult to roll out or do an upgrade on enterprise setting. And also, as I mentioned, sometimes the network provider, like an SDN provider, can add additional constraints of how often and which release you can upgrade to. So those were the reasons, but that's not what we are happy with. Like, we've done big jumps tried to do every 2 years, but moving forward, we are trying to do more frequent. So from the latest release that we are working on, we started getting onto Victoria, and we are trying to get upgrade story like done from the very beginning. So we would like to upgrade as frequently as possible. Every 6 months would be our target. And so we're designing our platform that way. And I think the granularity of upgrading different components is another thing we are looking forward to, as everyone touched upon. I think that helps us because not all services are easy to upgrade. So we are taking that approach as well. So we will upgrade one component at a time.
Yeah, and something that I've personally found is like the challenge with upgrades is actually most of the time how to have an effective process of being able to these upgrades, because that's usually the biggest reason why people are not doing these upgrades. There's usually pain points behind it. So for example, in very large environments, rolling out a change across a fleet of thousands of servers is not an easy thing to do. Whatever tool you're going to try to use for it, it's going to be painful. There's going to be small changes and differences. And so that's why we kind of took a few steps to get that to be as painless as possible. So, by using something like Kubernetes as the control plane for all of our cloud, we can easily roll out a change that just goes out, and Kubernetes just goes out and rolls it out across the entire fleet one by one. Because it's also image-based, like our host systems are pretty much as pristine as they can be. They just have like a kubelet running on them. And so that way, there is not much of a delta from one system to another, which minimizes that, oh, surprise, this system had this weird thing happen, and this other system had this other weird thing happen, and makes the rollout a lot easier. And then also, obviously, because it's very easy to replicate that environment, it's easy to just go ahead and see what the upgrade looks like in a kind of staging environment or something like that. So mainly, like, I totally see these issues, and I totally agree that they are hard things, but we found that it's mostly the tooling that makes it harder than it is the OpenStack itself. I mean, we've got a whole bunch of customers that we manage private clouds for. So not only do we have to do an upgrade in our public clouds, we have to do an upgrade for a bunch of other private clouds the users are running. And so we really needed to come up with a way of having the lifecycle managed really easily, because otherwise, if planning an upgrade, if we had to, for example, deal with some of the examples that Arnaud was dealing with, which is like it takes us like a year or 2 years to do an upgrade of a cloud. We would take us like 6 years to get like 3 or 4 clouds done. It'd be a lot of chaos. So we invested a lot in early infrastructure to get these sort of things going.
Well, I completely agree with you, Mohamed. The tooling makes a lot of difference when upgrading, and that can determine which is the frequency how you do the upgrades. But also OpenStack itself. So over the years, we've been seeing a huge improvement how OpenStack deals with upgrades. It's much easier today than like 5 years ago. There is no doubt on that. However, I still think that the developers still need to be more aware about the challenges of operators. We continue to see, for example, like between releases, configuration changes. That basically is not a configuration change. So it's just a group change of the configuration. And that causes so many troubles to operators to understand all of those changes and deploy them in a large-scale environment. That requires so many testing, and actually the outcome of that is not that much. It's just a configuration change that moved to a different place. So I continue to think that OpenStack and the developers need to continue to be aware about the operators' challenges, and have some careful as well. Be some careful before implementing these kind of changes.
I'll agree with Belmiro on that for sure, because we the majority of our time spent upgrading is in the testing. The rollout to like thousands of servers is really not a big deal. I mean, it's all on containers and there's tons of tools to do that. But it's really the testing, the database upgrades, the config changes, things that are unpredictable on a new release that we have to really just test everything before we gain that kind of confidence. And it could be better now than it has been in the past, but like it still takes us a while to get that kind of confidence that this won't cause us an issue.
So one question I had for those who had to do big jumps is, have you considered using fast forward upgrades, which is the community's solution for not having to go to each release every 6 months, but being able to basically do database upgrades in succession very quickly and only bring up the control plane from the release you upgrade from to the release you upgrade to? Because it feels like, from what I understand, you do not, like, it's more like a full upgrade approach where you just like migrate completely from one version to the other, rather than using the fast forward like intermediary upgrades in the middle.
It mostly depends on, some projects are able to jump from a release to a very newest release. We can do big jumps on some projects, but some of them we cannot, and we have to do these small steps. So it really depends. And I think it depends on from which release you are running on right now and to which release you are going to also. For example, right now we are in a situation when we want to upgrade Newton to Stein, and we know that Nova for this upgrade needs to be upgraded from. We need to go to every release in the middle in order to play online migration, offline migration, and when you are playing online migration, I mean, that's where you need to restart at least the control plane in order to Nova to bring back everything and make sure that the data is correctly set. We also do that, but we are not restarting everything. We just play the online migration in a container in order to simulate the starting of the control plane. So it's not totally what upstream is doing, I think, but it's something similar. And it led me to one question, but maybe I can keep it for later.
Oh, go ahead.
I'm wondering, because we are doing big upgrades, so we are shutting down every API on our side, and because we need to do upgrade of the database, and we are more confident doing that offline, because it takes, for example, 1 hour to migrate the data from a version to another. So my question is regarding how do you do, guys, to lower this time of migration? How do you even I think if you move only from one release to another, not a big jump, a small, it will take time for Nova. If you have a lot of data, it will take time to go over every line in the database. It can take up to, I don't know, 1 hour, and during this time Nova is not available, right?
Yeah, I mean, yeah, that's been a problem for us as well. I mean, it's we will tell our developer customers. I mean, like, we don't run a private cloud, or we run a private cloud, not a public cloud. So it's easier for us to tell our customers the API will be down because
Right.
they all work for us. So, but I mean, yeah, we've I guess sort of tried to solve it by putting the database on the most expensive hardware that we have. So that's pretty much how we do it.
People call that solving problems with credit cards. But something that we've done, and I've noticed helps a lot, is tidying up your databases. I found that most of the deployment tools that are out there don't necessarily put out of the box all the cron jobs that are available that clean up your databases. So for example, for Nova, you can run something that goes in archives and purges all the extra records and everything like that. So pre-upgrade, we usually try and make sure the database is the smallest possible database that it can be. Because especially in, for example, the context of a public cloud where you've got VMs going up and down all the time, you can really end up with some very, very large tables and stuff like that. And so, but even running that is also really stressing on the clouds, because usually what we've noticed is if it's not run for a long time, good luck. You're going to be locking a lot of your tables and it's going to be very hard. So it's almost like important to keep grooming your databases.
So basically we are running that we are trimming our databases every day. So that is part of our procedures. It's one of our cron jobs.
Yeah,
I'm also curious. Sorry, Tiahi. Now I have a question.
Go ahead.
Because, for example, on Nova and many other projects, we can do that. And Nova, it's actually a bad example because it has the soft delete. Many of the new projects don't have the soft delete. So that is not a real issue. But one project that I always have issues is with Glance, because because of some security concerns, you should not delete the image table entries, because otherwise someone can upload a new image with the previous UID. So how are you dealing with that?
On our side, I feel like we don't actually get that much images. I know you just published an article of 50 terabytes of images. We do get a lot of images, but generally, I also find that you're a bit lucky because Glance is not generally one of those large database migration projects. So I think we're usually pretty good on that front. I haven't had too many issues, but I do see your point.
Well, my point is, for example, CERN Cloud is running for more than 8 years, and that is one of the databases that will always continue to grow. At least there is no good solution now to avoid that.
Well, we came up with some custom scripts to still purge it, because actually we noticed as your database size grows, the Glance API slows down, and that itself slows down the VM boot time. So we started basically have some regular pruning script that cleans up both like older images and older VMs and everything, and that helps like keeping things sort of clean.
Yeah, we do cleaning also, but even with the cleaning, the database is still huge and data is still taking time to migrate. Okay.
Yeah, I guess that leads to the next. We already talked about a lot of the database best practices you have, but do you have any other best practices to make the database upgrade, which has been mentioned during the first part of this show as one of the most painful part of the upgrade process? So is there any other tips or tricks that you're using to make that part of the process less painful? And I guess that also applies to other external services upgrades like RabbitMQ. How do you have any secret sauce that you apply to make the RabbitMQ upgrades and the database upgrades less risky, less painful, less lengthy, I guess?
I think it depends on how you use Rabbit. I know some deployments use Rabbit purely as a message queue, while other deployments use Rabbit as an actual like state thing that actually contains state, and they'll have notifications, and losing the state of RabbitMQ is a bad thing. So for some deployments, what we've done is split that into two different RabbitMQs, because the one that we care about state is actually a little bit more of, doesn't have that much traffic, but it needs to really make sure that it's very stable. Whereas another one that is kind of like okay, things have blown up, so we just kill this cluster and we relaunch it, and then messages start flowing again. Because honestly, sometimes that's what you just need to do for Rabbit. You just got to shut it all down, bring it back up, because the pace at how quickly things can kind of get to a meltdown stage when Rabbit is not feeling too good is very quick, and you just want to kind of get it back and up and running. So that's one of the things that we do. We run RabbitMQ inside Kubernetes using OpenStack Helm, which provides that. But one of the things that were discussed recently at the PTG, which is the company behind RabbitMQ, it has started to build a RabbitMQ operator. And so operators in Kubernetes are great because the folks that build these applications can put all the logic into recovery and all this stuff that we don't know anything about and can encode it there. So that we can have it running inside Kubernetes and managed by an operator. So the operator would handle things like upgrades and making sure things are properly done, and have computers solve that problem instead of humans.
So the way that we solved this was to run as much databases as possible and RabbitMQ as possible. So we run more than 80 different MySQL instances and more or less the same number of RabbitMQs, because we run a different SQL instance for each Nova cell and for each OpenStack project. Means that we don't have clusters, so which makes the upgrades very simple. We have only 2 RabbitMQ clusters. One is for the Nova, the top cell level, and the other RabbitMQ cluster is for Neutron. For those, we try to not touch them as if they are working well. So we don't touch them, and we upgrade them early, every year or every 2 years if there is no security issues on them. However, the others, the simple RabbitMQ running for the instance every time that there is a new package, it's upgraded like any other package. There is no issue with that.
Just a question on that, Blamir. Do you run a single instance of Rabbit per service, or do you run clusters per service?
So is what I was trying to say. So I only run one RabbitMQ instance per
cell. So no clustering is involved?
So clustering is only for Neutron and the Nova at cell level, and notifications that I forgot.
Okay, got it.
Any other database or RabbitMQ upgrade tips before we move to the next topic?
About Rabbit, I can just say a few words. We had to upgrade Rabbit in the last year. To do that, we had to stop the Rabbit cluster for each region. So we are running one Rabbit for one region. So it's kind of a big Rabbit. We would like to move to separate the Rabbit just like you do, Belmiro, but it's not yet done on our side. Anyway, to upgrade the Rabbit from doing a major upgrade of the Rabbit, we did it by just shutting down the old Rabbit cluster and starting a new one. I think it's doable if you do small upgrades as well. You can cluster new Rabbit with old Rabbits, but you have to take into account some specific things. We were doing a too big jump for this situation, so we decided to just shut down everything. But it's quite easy, and because the data is like Mohamed said, there is not so much data in Rabbit. It's just moving messages from a service to another. So it's done very quickly, let's say.
So I have a question. So our experience is upgrading RabbitMQ clusters is always messy. It's always so risky. So that's why we try to avoid it. But considering what you said, that you just shut down the old one and bring up a new one, that means that, for example, compute nodes connect to the RabbitMQ using a load balancer. You don't connect directly to the cluster.
No, we do connect directly to the cluster, but we have this puppet which is able to change the configuration of Nova on the compute. So we
Right.
did,
But
yeah.
that takes a lot of time, no? In thousands of nodes. That's
Not that much. We can, not that much. No.
okay.
Yeah.
Okay, let's go to the next section because we already touched on a lot of those questions earlier when Mohammed mentioned benefiting from running everything containerized on Kubernetes. So in terms of deployment systems, during the presentations on the first part of the show, we saw a range of approaches from Vexxhost using low-key images and OpenStack Helm and Kubernetes, to others more holding their own system using containers deployed using Puppet or other systems. So for those using community-maintained deployment systems like OpenStack Helm or OpenStack Puppet, are you able to rely on the built-in upgrade capabilities in those tools, or do you have to design your own upgrade tools? Is it more used for deployment, or can you also use the upgrade button in those systems in your large-scale deployments?
So I think I can start, given that I'm like a serial deployment project user. So I've been PTL for Puppet OpenStack. I've been PTL for OpenStack Ansible, and currently using OpenStack Helm. And I've also worked a little bit with Kolla Ansible. So I've done my fair share of going around. And I think for the most part, it really kind of depends. So it depends on the project. So OpenStack Helm and Puppet OpenStack, I find to categorize them in more of a library. They're kind of like, here's a Helm chart that lets you deploy everything, but it's not like a give me a cloud button, which is really useful for, I'd say, more advanced operators. So someone like, for example, CERN or us, where we're like, I don't want to write all of this from scratch, but I want to kind of be able to glue it all together with my own requirements. And so that's something that's really nice in OpenStack Helm and Puppet OpenStack. I think I see OpenStack Ansible and let's say something like OO in a different category, which is like a kind of a fully managed A to Z, which is I will get you everything from onboarding Kolla Ansible as well along that, which is kind of more of a distribution, I would call it, that it actually gives you everything from A to Z. You just give it like IP addresses of systems and it goes ahead and deploys everything for you, but it will deploy it in the way that it likes to deploy things. But it'll give you the option to tune some things and change some things, but you're not going to like fundamentally change the way that it goes about doing it. These projects tend to have upgrade jobs. So I know for a fact OpenStack Ansible had upgrade jobs and were running for a while. And we pretty much had an upgrade script that it ran, and that was the same thing that was suggested that you run in your own deployments. So it would cover for the most part like a normal upgrade from one version to another. Now, obviously, there's like these kind of corner cases where, you know, when you're running an upgrade on an empty cloud that was installed 5 minutes ago versus running an upgrade on a cloud that's been running for 8 years, there's maybe going to be timeouts. There's maybe database that are going to take longer. There's going to be this weird record that was created by a version of OpenStack like 6 years ago that has now broken the migration, and they have to manually fix it. So like in theory, it should work, but there's always like the, you know, be ready for some stuff to look into.
Yeah, we prefer to manage all the process ourselves. For example, OpenStack Puppet, as you mentioned, we always disable, this was from the beginning, it was quite scary at the beginning, that option to synchronize automatically the databases. Of course, we patched that immediately to stop that. It was so scary to run that. And yeah, we try to control all the process. We don't let the orchestration tool to do it.
We used OpenStack Chef, which used to be a, well, OpenStack project, no longer anymore, and they didn't have an upgrade story, so there wasn't much to do. But moving forward, we're going with Kolla Ansible, which has a upgrade, but as Mohammed Nasser mentioned, like it's very prescriptive in ways. Where we'll see how that goes.
Yeah, on our side, we mostly use OpenStack Puppets, but more in a library mode, just like you described, Mohammed. Not for upgrade.
Yeah, and we are not using anything as far as deployment tools. It's all just building our own containers from upstream code and deploying it with config management like Puppet to handle that.
Okay, I think we had a question around Airship, and if any of you considered using it. Yes. So do you all ever deploy OpenStack with Airship? Is this really easy to upgrade compared to like a more traditional package-based deployment?
I can briefly So Airship helps you. One of the components of Airship one of the things you can deploy using Airship is OpenStack using OpenStack Helm. So we're kind of using some of the components. Airship 2 recently came out, which pretty much does a lot of the things that we already do. And so we're looking at seeing how we can kind of adopt it. And what's cool is the developers behind Airship are all running clouds that are running on Airship 1, and they're having to come up with an adoption method. But what's really cool with Airship is it really allows you to manage the entire life cycle of a region, from hardware to applications on top of it, to secret generation, to everything. It's a whole stack, and so I think it would be really awesome, and that's something that we're definitely looking into, especially as we manage multiple deployments and having a way to do infrastructure as code, which is what we do right now. I don't know if it's much easier to upgrade. I can't comment on that.
Yeah.
Any other comment on Airship, which is an open infrastructure foundation hosted project to help with deployment of infrastructure for clarification? Well, if not, we'll go to the next section where we mentioned last 3 weeks ago, we mentioned that operating systems upgrades are another major pain point that you all mentioned in your presentations. So while OpenStack can be upgraded without loss of service, the operating system upgrades still seem to trigger some amount of downtime. So can you explain how you handle those upgrades? What's the impact on your deployment? And if you have looked into the less disruptive ways of doing operating system upgrades, like live kernel patches and other modern systems.
We tend to just we'll tend to just do a full fresh install of the OS anytime we do an OS upgrade. All of our control plane components are on containers, so it doesn't really matter what OS is there, and that saved us a lot of pain points, just putting those in containers and not worrying about what the OS is underneath it. So that really, we don't really, it doesn't factor into our upgrade plan much. We just upgrade the OS as needed. We just do one at a time, and the APIs are usually able to stay up during that time. So as far as the computes go, though, I mean, those because we do use NUMA pinning, we have difficulties with live migration. So we do need to migrate VMs off the computes in order to actually do the upgrades do the OS upgrades on the computes. That's really the biggest pain point, is not having live migration with NUMA pinning right now.
Yeah, the control plane is quite easy to replace, no big deal. The hard part is the compute, like you said, Joshua. And for this, we usually run two different operating systems. For example, Ubuntu 16 and Ubuntu 18. And we can run the same OpenStack version on the two operating systems. So if we want to move from 16 to 18, it's just a matter of live migrating every instance from a compute, reinstall it, and it will run the same OpenStack and bring back into the node of the pool of nodes for the region. So it's just a matter of live migration, basically. And on our side, we are really used to live migrate a lot. So we have automation around this. We deployed some Mistral workflows in order to do that, and it's quite easy now.
So Arnaud and Joshua, follow-up question, like, can you live migrate across OS releases for computes? Is that what you're saying?
No, usually when we upgrade OpenStack, we upgrade, so we replace the control plane, completely new, but hypervisor are still running the old operating system, but we install the new compute agent and neutron agent on this old operating system. So it's running the new OpenStack release.
Yeah, and you can make live migrations. So QEMU supports live migrations from the QEMU in 1804 will accept a live migration from the QEMU in 1604, for example. But usually this live migration back out is generally not supported. So you can live migrate from a 1604 to an 1804 machine, but you could maybe migrate from 1804 to 1604, but you'll probably not be supported. And so that's something that the distros try to help support, is make sure that they support live migration cases across different operating systems. And
is that the same? Sorry,
yeah.
go ahead.
Yeah.
Yeah, just about QEMU on libvirt. We solved this by just rebuilding the same QEMU and libvirt version on both operating systems.
Yeah.
Is the same story applies for CentOS? Belmiro, do you have any comments there?
So our experience on this was when we moved from Scientific Linux 6 to CentOS 7. This was some years ago. At that time, we are not able to live migrate instances, and we are not able to do an in-place upgrade of the operating system. So at that time, basically, we start deploying the new servers that arrived on CentOS 7, and the ones that were on Scientific Linux 6, they stay there until end of life. However, this time, we will try to live migrate instances between CentOS 7 and CentOS 8, or CentOS Stream 8 or 9. We are not able to test it yet, but that will happen soon. Yeah. In our case, because the control plane runs on virtual machines, upgrading the control plane operating system is quite easy. We just replace the virtual machine with the new OS. The real issue is really the compute nodes. So we will try this live migration between the different versions.
Yeah.
I also think live migrations have come a long way from, when you're talking about migrating from Scientific Linux 6 to 7 versus, where we are today. It's become a lot more stable in my experience overall. But just to kind of close out, on our side, we do similar thing to what OVH does. So, live migrate, and swap the host from underneath them.
So Thierry's question also touched the kernel upgrades in the compute nodes. So I'm curious as well to hear how you guys are doing that. So what we are trying to do, because that was always an issue, so to not disrupt VMs, we had the compute nodes running for a long time without a reboot. So we are now trying to live migrate again, live migrate. So we build a tool, and we are trying to leverage that to basically going through all the cells and empty the compute node, automatically reboot the compute node, get new kernel, and make it available again to the OpenStack scheduler.
Yeah, that's exactly what we did. We used a Mistral workflow in order to do that. So we built a Mistral workflow, and we just empty a compute, install the new kernel, reboot, and move over to another one.
I don't know. You use block storage? Your instance only boot from block storage, or you also have ephemeral disks?
We also have local disk. We have both, actually. We have more local disk than block storage.
Okay.
So yeah, it can take time because you have to move the disk to the other compute. Yeah.
Yeah, it takes a lot of time, and at least in our experience, sometimes it's extremely slow. We don't understand yet the issues. Yeah.
You have to enable some flags in libvirt. It depends on which version you have, but some flags in recent libvirt version are helping a lot to migrate, especially if the instance is having a high load, high CPU usage, or high RAM usage. Some of them, yeah, we still have some very few instances which are not being able to be live migrated. And for these specific cases, usually we try to contact the client and we just make an arrangement in order to shut down the instance during the operation.
Yeah, is what we've been doing.
Yeah.
Okay, well, it's time for us to address direct questions from the audience. I think we have a few questions lined up. First one on usage of containers. Yes, is there someone here who is not using containers, or is everyone already moved to containers? And I guess that leads to a wider question for those who don't run containers, do you wish you could run containers, and what's preventing you from running containers? Or do you see the exact same flexibility with other packaging systems?
So at OVH, we are not using containers yet. We are moving on to use containers. So some of the services are running on containers, but most of them are not. It's not a big deal, in my opinion, because at OVH, the main idea is to manipulate a dedicated server, and we have a lot of automation around manipulation of dedicated servers. So it's quite easy for us to manipulate a dedicated. It's not as easy as a container, of course, but we have a lot of robots which are installing images, building custom RAID devices, stuff like that. So it's quite easy for us to manage everything using dedicated servers. But it's because OVH has this specific mechanism.
I think we're still not on containers on the computes. I think there was some issue we had with the Neutron Linux bridge agent that we've left that in a Python virtual environment to have both Nova and Neutron agents that are running on the computes at least are still in virtual environments and not containerized. But the control plane itself is all containers.
So in our case, we are testing. So we have an entire region. When I say entire region, it looks like a lot of things, but it's a very small region. And that it was completely deployed using Helm charts, like Mohamed mentioned, even the compute side, and allow us to test several things. And then in the main region, we also have, for example, Glance, that half of the traffic of Glance goes through a setup that is on top of containers. So we are testing different ways how to deploy and how to manage OpenStack deployment based on containers.
We used like packages before, but we've moved onto containers, and like we containerized like existing deployments, but like moving forward, the new deployments are fully containerized, as I mentioned, like going with Kolla Ansible. And one of the reasons we want to do it is it makes keeps things isolated. Like in our, let's say, controllers, we were running multiple services. Let's say it's like Nova, Glance, everything runs. And sometimes, even if it's not an OpenStack, we actually had an issue where some other package, Python package, getting installed on the server for, let's say, security reason, interacted with another package and caused other problems. So that's one of the major drivers of keeping things like as isolated as possible.
Yeah, in our case, we're pure Kubernetes all the way. There's nothing that the host gets touched. It just runs kubelet, and that's it.
Yeah, and to be clear, when we say running on containers, it's running OpenStack on containers, running OpenStack itself, deploying OpenStack itself, the control plane, using containers and or Kubernetes. It's not like a about VMs versus containers, which is another topic for workloads. So it's OpenStack on containers, not containers on OpenStack or VMs on OpenStack. Maybe next question from the chat. I haven't looked at what we have as questions. Feel free to still ask questions. We still have a few minutes until the end of the show. Or anyone else has questions between yourselves? Oh, okay. On the topic of removing images and the security side of it, a topic we discussed earlier, I'm wondering where does the concern come from? Neither the user nor the operator can set the UUID in the image without DB intervention.
I think it's related to a link between Glance and Nova, right? If an instance is booted on an image ID which is deleted on Glance side, and if Glance reuse the same random ID, it could lead to some issues, right? Maybe Belmiro, you know more.
So actually, the Glance API allows the user, if it's in the policy, to specify the UID of the image. And that was done a long time ago, basically to allow replication between different sites, different regions, having different glances, and they needed to keep the same UID. So depending on the options that you have enabled in your infrastructure, that could be an issue.
So it's just a matter of policy, right?
Yes.
Okay, one last question. Have you seen production use cases where OpenStack is managed by Kolla Ansible? I guess that's one for Mohammed.
Well, I think I know there's one like right next to you, Thierry, that is running that. So maybe, because I know Imtiaz, you mentioned you're using Kolla Ansible.
Yeah, so we are using Kolla Ansible. Well, it's not yet in production. We're just working on the latest Victoria release, but we'll be in production soon, like later this year.
Yeah, but other than that, I know that of a few deployments that are there's probably a lot of deployments that use it. I know there's a lot of the companies that build kind of deploy clouds, especially more, I think, in the HPC side. Stack HPC works a lot on Kolla Ansible, and a lot of their deployments are using Kolla Ansible for this sort of thing.
Okay, I think it's time for us to wrap up the show for today. I want to extend my thanks to all of our great speakers today. I really appreciate you all joining us and sharing so many insights on your large-scale deployments. Next week on OpenInfra Live, we'll have another great episode lined up with Victoria Martinez de la Cruz. We'll be joined by several other members of the community to talk about internships, mentoring, and how to get started contributing to open infrastructure projects. So it will be an awesome discussion on the power of mentoring in open source projects. So mark your calendars and feel free to submit ideas for future episodes at ideas.openinfra.live. I hope you will all be able to join us next Thursday at 14 UTC for this mentoring episode. And thanks again to Belmiro, Joshua, Arnaud, Mohammed, and Imtiaz. And see you all next week on OpenInfra Live.